messed up on yesterday's video. So I have both of these solved. The first one we solved for y. So we've got that y-intercept of -5. And our slope is -2. So we're going to rise 2, run left 1. And I like to plot a lot of points when I'm graphing a system because one of these hopefully will be our solution. For our red equation, we did that one with intercepts. So my y-intercept is 0, 1, and my x-intercept is 2, 0. From there, I noticed that the slope is -1/2. So I'm going to continue that slope, rise 1, left 2, and found my point of intersection. So the solution to the system is -4, +3. Alright, so here are the practice ones that you guys should have tried before you're watching this video. For our first one, I would not do the intercepts on this one because I noticed my x-intercept would be 20. So I'm going to go ahead and solve this one for y. I'm going to add y to both sides and subtract 10. So I get 1/2 x minus 10 equals y. So my y-intercept is -10, and my slope is 1/2. So rise 1, run to the right 2. Remember, slopes that are positive means the line is rising from left to right, and slopes that are negative means the line is falling from left to right. So that's one way to check that you're getting your line graphed correctly. Alright, so our absolute value one, inside the asylum we have that -2, which means our vertex is at +2. Outside the asylum is normal, +5. So we plot our vertex. And then because there is no scalar on the outside or inside the parentheses, our slope is 1. So we rise 1, run 1 in each direction to get that V shape. For our inequalities on this one, when we distribute our 3, we get 3x plus 4 is less than or equal to 3x plus 6. Subtracting 3x from both sides, I get 4 less than or equal to 6, which is true. Since our x is canceled and we have a true statement, that means all real values will work for x. So if you're going to graph that on a number line, you would just shade the whole number line. For our second one, adding 1 to both sides, dividing by 2, or if we like that as a mixed number, x is greater than 5.5. Multiplying both sides by 2, because that's a positive value, I don't flip the inequality. So for my first one, x is greater than 5.5, and for some reason our number line isn't set up correctly. So we'll do, at 5.5 we have an open circle because it's just greater than. At 10 we have a closed circle because it's greater than or equal to. For our first one, because this is an and, we only shade where they're both true. So for my first one, I will be shading it towards the right because it's greater. As well as for my second one, I'm shading towards the right because it's greater. So if you think about extending this arrow, where they overlap is off to the right of 10. So where both inequalities are true is where x is greater than or equal to 10. All right, so in our absolute value inequalities, we're going to split this up. We've got 5x plus 2 is less than or equal to 7. And remember the cheesy saying, less than means and. 5x plus 2 is greater than or equal to -7. So we flip the inequality and we make the answer negative. Solving, I'm going to subtract 2 from both sides, divide by 5, and do the same process over here. Subtracting 2 from -7 gives me -9. And if I want this as a mixed number, this would be -1 and 4/5. So when I'm graphing this, I would have 1, -1 and 4/5. I have a closed circle on both of these because they're both or equal to. For my x is less than 1, I will shade to the left. Greater than -1 and 4/5, I shade to the right. So this one, the solution is everything in between those values. As a reminder with the absolute values, and should always be shaded towards the center, and or should be shaded away. So that's a check that you solved your absolute value inequalities correctly. For our second one, the first thing that I need to do is divide by -3. I cannot distribute into an absolute value. It doesn't work the same way as parentheses. So once I divide by -3, I flip the inequality. 21 divided by -3 is -7. Now because absolute values are always positive, I know that any value I put in for x, once I take that absolute value, it will be positive, which is greater than -7. So this is all real numbers. And again, we're going to graph that on the number line. It's everything. Graphing system. So my first system, my first equation, I notice that both of those intercepts will be fractions. So I'm going to go ahead and solve for y. Subtracting 3x from both sides and dividing by 4. When I plot y-intercepts, I like them to be as mixed numbers so I know where I'm plotting them. So -7/4 is the same as -1 3/4. So just shy of -2. And then my slope is -3/4. So I'm going to rise 3, run to the right 4 from my y-intercept. Sorry, run to the left 4. It's negative. Your line should fall. Have to do that with the fraction. And then I can also fall and run to the right. All right, for my red equation, this one's easy to solve for y, so I'm just going to subtract that 2x. -3 is my y-intercept, and -2 is my slope, so I can rise and run to the left. And it looks like that's where my solution is. So I have -1, -1. Now on this one, especially since that y-intercept wasn't an exact value, I'm going to check my answer and see if it works. So for my blue equation, 3 times -1 plus 4 times -1, does that equal -7? -3 plus -4 does equal -7, so that one checks. For my red equation, the substitute, I'm going to go back to the original just in case I made a mistake when I was solving, and that way I'm checking the correct equation for sure. 2 times -1 gives me -2 plus -1 does equal -3, so that one checks as well. So that's our solution to the system. Graphing systems of inequalities. Our blue inequality is just greater, so that will have a dotted line. Sorry, I tried to tap on the board to get rid of that, but it didn't work. So we've got -3 for our y-intercept, and our slope is -3, so we're going to rise 3 and run to the left 1. Or fall 3 and run to the right 1. And again, dotted line on this one. For a red inequality, we have an or equal to, so this will be a solid line. Y-intercept at -1 and slope of 1/3, so rise 1, right 3 this time. All right, so now we need to see where to shade when we've got those inequalities. So for my red line, neither of my lines go through 0, 0. So I'm going to substitute 0 into my inequalities and see if they're true. Is 0 greater than -1? Yes. So I will shade towards 0, 0. For my blue one, is 0 greater than -3? Again, the answer is yes. So I shade towards the origin from my blue line as well. And right here is where my red arrow and my blue arrow are pointing at each other. So that's the solution of my inequality. All right, last slide, looking at the quadratics. So we start with factored form. So my x-intercepts, because they're in the asylum, are +4, 0, and -2, 0. To find the vertex, I take the average of my intercepts. So in this case, my Axis of symmetry will be x equals 1. To find the y value, I substitute that in for x. So I get negative 3 times 3, or negative 9. So 1, negative 9 is my vertex. And then I can use those 3 points to graph the parabola. Again, make sure the parabola is rounded like a U versus pointed like the V shape for the absolute value. For my second quadratic, this is in standard form. So to find the axis of symmetry, I use the formula x equals negative b over 2a. Remember, we've got our a, b, and c. So negative b, or the opposite of b, would be negative 2. 2 times negative 1. So I get an axis of symmetry of positive 1. Substituting that back in to solve for the y-coordinate of my vertex, I get negative 1 plus 2 plus 3 gives me 4. So my vertex is at 1, 4. And this one does factor. Scroll down here so I can factor. I'm going to factor the negative out because whenever you've got this negative coefficient, it's hard to get it factored correctly. So I just factor the negative out before I do my T-chart factoring. And I should probably actually factor the negative out. So that would be a negative 2 plus negative 3. So we're thinking about what multiplies to a negative 3 and adds to a negative 2. So I usually set up my binomials, and I know the only numbers that multiply to 3 are 1 and 3, so then I figure out my signs. If the 3 is negative, then I'll be adding to a negative 2. Negative 3 plus 1 gives me that negative 2. So I've got my x-intercepts of negative 1, 0, and 3, 0. So I plot my vertex, so we've got negative 1 and 3. And that's enough to go ahead and graph my parabola. And it is consistent with that negative a value opening down. And on my first one, my a value was positive, so it opened up. And finally, we've got vertex form. So our vertex in the asylum, we've got that positive 1, so it's negative 1, positive 3. There's my vertex. And then on this one, again, there were 2 methods to graph this one. I prefer the y-intercept method. So I'm going to substitute 0 for x and solve for y. So we got negative 2 times 1 plus 3, negative 2 plus 3 is 1. So my vertex, or sorry, my y-intercept would be 0, 1. And then I like to use the axis of symmetry through the vertex. Wait a minute, sorry guys. My vertex was negative 1, 3. That was my y-intercept. This is the 3rd time I've recorded this, so I'm not starting over from my mistake. Alright, so then we reflect that point over the vertex, and then we get our parabola, again opening down. So I reflected this y-intercept over the axis of symmetry to get this point to finish graphing my parabola.